Hey, scholars. Talk about theory of constraints, bottleneck math, bottlenecks, and linear programming. First, what's a constraint? A constraint is the weakest point in your operational process. It's where you're most likely to have a blow up or a blowout, which is what happened in the two major examples in the book. We had a blow up with the Challengers, or we had a blowout with the BP oil well. Both of them major issues caused by operational managers screwing up and not doing their jobs, period. So as an operation manager, critical that you understand these constraining points and critical that you're able to do something about them. So how do you understand them? I put them in the book 4 ways. Really, one of them's kind of a way to fix things. But the first is to test, measure, and observe. So let's say you're a trucking company, you know what your constraints are. My constraints are going to be based on the number of trucks I have and the number of drivers that I have. So what do you do about that? You got a good forecast. The forecast says, hey, come September when I'm doing pre-holiday deliveries, I have to have twice as much capacity. What do you do? I don't know, maybe you deliver at night and you hire some other drivers temporarily to do that. Maybe you get more trucks through some truck leasing company, but you figure out a way to work around your constraints. The next is push the system to its limits. Be it a factory or a restaurant. I used to run a restaurant, excuse me, and running the restaurant, once in a while we'd have a weekend or even a week where it just got nuts. And I would observe. I'd say, wow, I have got to get these cooks better trained because they're okay at their own pace, but when they pick up, they're not okay. So I'd spot the constraints and then I'd work towards fixing those as we went forward. And pushing the system to the limits sometimes will be done in a laboratory. Obviously, you wouldn't send a space shuttle up in freezing weather to see whether it worked or not. You would test it in the laboratory and test the various components. And some of us may or may not have jobs at some point in time where that type of testing would be possible. The next is wait for an error to occur. We talked a little bit about Six Sigma. We talked about standard deviations. And if you're running at a Six Sigma level, you have 3.4 defects per million. You don't have a lot of defects. So when something goes wrong, then you study it and you figure out what happened and then you fix it. But even if you're operating at a 1 Sigma level and you want to fix things, what I do with my clients is I'll say, all right, well, let's track it for a week or a month or whatever the right period is, and let's take a look at what kind of issues we're having, where our quality isn't where we want it to be, and then let's fix the worst one. Fix that one, make it right, keep measuring, fix the next one, keep measuring, and just keep fixing things one at a time. And it's really quite an effective strategy, and it's a good way to look at constraints in the business and to use that information to improve the business as we go forward, or the operation. And the last, number 4, is available technology, and know the available technology and what you can do with it. I give the example of a hotel room key, a major constraint to old hotels, and the reason that a lot of them went out of business was the customers didn't feel safe there. Guests didn't feel safe there because, well, the last 10 people that left this room didn't all turn in the key as they left. You haven't changed the lock on the key, the lock on the door, so their key is going to work. So, I'm in there at 2 in the morning and all of a sudden somebody comes and pays me a visit. Well, I don't feel very safe about that. So, that was a major constraint. Obviously, the technology for the new keys has gotten rid of that constraint. It's no longer an issue. You can still bust down the door. Certain things we can't do anything about, but we can use technology to improve our processes and to get rid of possible constraints. All right, let's talk about bottlenecks. What's a bottleneck? A bottleneck is the point in your process where you have the least amount of capacity. How do you calculate that? If you're running a factory floor, you look at your machines. You look at what it takes on each machine to produce whatever you're producing. And then you find the machine which has the least available capacity, and that's where your bottleneck is. Sometimes that capacity, you still may have 50% capacity, so your bottleneck is that wide. But when your bottleneck starts getting skinnier and skinnier, and at some point where you actually can't produce everything, then as an operation manager, you need to figure out, what am I going to do? And I ask in class, what are you going to do? Are you going to produce what? And everybody pretty much says, I'm going to produce the product that has the most profitability. Well, that's certainly not a bad answer. It's just not the right answer. So what we want to do is I'll read it out of the book. We want to maximize the bottleneck. So we're going to produce as many products as we can at the bottleneck. And what we're going to do is we're going to do an analysis and we're going to say, what's the operating margin per minute at the bottleneck? Then we're going to start with the product that has the highest operating margin per time, the bottleneck, and then we'll just go down from there. And showed a couple of examples in the book that went through why that math works and how it works. But yeah, you probably have to get to the sophistication of 5th grade math to really be able to handle that. So I'm not going to go into a lot of the math. It's quite simple, adding, subtracting, and multiplying and dividing. But it's important to understand. In the example in the book, it was 20-25% more profitability because you bothered to do the math. The next thing that we talked about was linear programming. And what's linear programming all about? Well, it's a lot like bottleneck math in that you're trying to figure out where should I schedule my production given capacity constraints that I have. And I give an example in the book. It starts on page, looks like about 117, and goes through linear programming. Linear means line, and you've got an XY axis, and then your XY axis has data points. The formula for a line, y equals mx plus b. So you're going to have a data point on the y-axis. You're going to have a data point on the x-axis for each of the products that you're producing. We're using a 2-product scenario here, which is easiest. But you could use 20 products and have the same kind of math done and get a little bit more, wouldn't get more complicated, it'd just get bigger. Anyways, so what you do is you lay out using the math, what am I going to produce? And the book goes through the calculations for defining the slope of those lines. But essentially what you're doing is you've got 4 points. You've got the y point where you're producing none of one product, and then the x point where you're producing that many of the x product. So product 1 you produce 0 or 10, and product 2 is just the opposite. You produce 10y and 0x, and so you got a line that goes down from the y-axis to the x-axis, and the same thing for the second product. And then where those intersect is going to be your 4th point. Of course, the 3rd point is the 0, 0 point where you're not producing anything. And so then your job is to just basically do the math and say at which one of the points, because it's always going to be at one of the points, is my operation the most profitable. And then again, that's relatively simple math. This probably gets up to about, it's probably high school algebra. And you calculate using simple addition the most profitable mix of products, and that's where you produce. That's it. I think that's enough for this subject.